Hello, welcome back. So, at the very first of the session, I have mentioned that the output or the word to vector, what we have generated, or the word to embedding what we are generating, will be of the size 100, right? So, we have also tested that out here, right? So, the model.mv, so we have just able to check that size as 100. So what this size is basically, this is the size of the hidden layer, right? In the previous diagram where I explained, so you could just like refer to that, saying that we are just removing that hidden layer and we are using that as a embedding, right? So what if this if we alter the number of neurons over there, or what if we reduce the size of the hidden layer? What if we reduce the size of that hidden layer from 100 to 50? And how does this affect on the training of the Word2Vec? Let me just check that here with the sampling here as well. So I'm using one of the decomposition technique, or a number of parameter reducing technique called PCA. So I'm using that PCA to reduce the number of components exactly by 2. That is, it will be dividing the number of neurons in the hidden layer exactly half of it. So instead of 100, now it has reduced that entire set of word to vector, that is the word to vector which is generated here, into 50. So by doing this, I am reducing the number of reducing the number of size, or the number of neurons present in the hidden layer. So all these steps I am going to do those as well. So you could just see one of the plot which I could able to see that. So this is the word vector, or the word to vec, how the word to vec will be looking like. If I just plot it on a 2D diagram, you can just see that these are the words which are closely related, or the closely contextual words. So suppose if I give the word input as a canals, and I can't expect this obey as a predicted word, right? Because it is far away from the word canal. So there is no sentence or a context where the neighboring word for the word canal would be obey, or the Alabama, or the Georgia. So only those words will be appearing as a context terms, or the neighboring terms which are closely aggregated over here. So in this zone, what you can see it over here would be the predicted word. If I just pass the word any of these, so if I just pass the word by bribery, and I could expect these words as a output, the survivor, or the Danube, or the any words which are present in this last text compilation over here. So now, if I was mentioning that I have reduced that length to 50, right? So now, if I reduce that length of that word to vector to 50, and if I just see, or if I pass a word money, and see what are the nearest neighboring words for the word money. So you could just see for the word money, it has predicted like credit, profits, payments, funds. So generally, where this word money appears, these are the neighboring words for that. So this one we have actually not tested before, right? So the one we tested was for the queen, right? So we'll just pass that same word queen. Now just check what is the result. See here, you could just drastically see that the word Elizabeth was at the top of that, right? So that now it couldn't able to identify those relationship, or the it couldn't able to identify those neighboring words as Elizabeth, because it couldn't able to recognize, or it did not have sufficient weights in order to understand that Elizabeth word appears closer to the word queen. This is what happened. So this is what happened when the training happened, right? So what it would have learned would be insufficient because of the reduced number of neurons in the hidden layer. Clear, you could see I have reduced it to 50, right? So that's why it has reduced to the performance of that Word2Vec embedding has reduced drastically. And in another way, we can also check it with another example where I used for the word woman and king. So I am expecting woman and king as an input word, and negating out the man context. Then I should be expecting queen as an output, right? So here it was perfectly well when it was when it was a size of 100. But what that would happen for the uh, reduced length or the reduced size of the word embedding. If I pass the word woman and king and negating out the man, you could just see the different words out here. You are not just seeing that word queen here already. So this is very like a live example of insufficient training or the insufficient what you can see training corpora for the Word2Vec. This is what we can see in the current approach which we have done. So this comes out at the end of our basic hands-on or hands-on exercise for Word2Vec. We can use this Word2Vec embedding to and train with a large amount of text corpora, and we can just use this to design a website or design a certain application where we wanted to know the context of the word or the similarity of the word, where the contextual neighboring words could appear for a given word.